Okay, let's talk about integration by substitutions. You can think of this as the reverse chain rule. So it isn't really, because remember, integration is just the opposite of differentiation, so everything is just reverse. So you can think of this as the reverse of chain rule. So what do I mean by the reverse of the chain rule? So let's say you had y is equal to, now let's make it a bit difficult. Let's say you had 2x plus 1. That's pretty easy. But then let's say you had it to the power 8. How would you integrate that? Well, one way to do is you can do 2x plus 1 times 2x plus 1 times 2x plus 1. You can do it 8 times, and then you will get a big polynomial with a power 8, 7, 6, 5, 4, 3, 2, 1, 0. And then you can integrate each term by term and then get the final answer. Or you can use integration by substitution. So what you do is, let u equal 2x plus 1. Right? You have u is equal to 2x plus 1. What's the derivative of u with respect to x? Well, that's just differentiating this term right here with respect to x. Derivative of 2x plus 1 is just 2. We should know that by now. And now let's rearrange this. So we're trying to find integral of y with respect to x. This is what we're trying to find, right? So if you rearrange this, if you bring dx to the other side, you have du is equal to 2 times dx. And then if you leave dx on its own, you have dx is equal to du divided by 2. So you have that right there. So now this becomes, so you had integral of y is 2x plus 1. So you have 2x plus 1 to the power 8 with respect to x. But now, instead of x, let's use u. So now 2x plus 1 is actually u. So now you have the integral of u to the power 8. And now instead of x, you have du over 2. So that becomes du over 2. Well, what can we do now? We can bring the half outside. So we have a half times the integral of u to the power 8 with respect to u. And this is a much simpler integral. This is a normal integral. You can use the reverse power rule. And you have a half times u to the power 9 divided by 9. And that's it. But there's one more step actually, because u, we don't want the answer in terms of u because we're always working in terms of x. But u is equal to 2x plus 1. You can just put that back in. So you have that is equal to a half times 2x plus 1 to the power 9 divided by 9, which is equal to 2x plus 1 to the power 9 divided by 18. Plus c, of course, because it's a definite integral. So you can see, instead of expanding all these brackets out and you get an insanely long polynomial and then you integrate that and then you factorize that, instead of doing all of that, we can let u, this is also called integration by u substitution sometimes, because we let u equal 2x plus 1. Like how in a parametric differentiation we let t equal something, we let y equals something in terms of t and x equals something in terms of t. Now we have u is in terms of x. It's just, it depends on what you want to use. You can use u, you can use s, you can use t, you can use x. You can't use x. You can use anything else you want. So yeah, you let u equal the thing inside the brackets usually, and then you recognize that when you take the derivative of u with respect to x, you just get 2. And then you can rearrange, you can treat it as fractions even though they're not, and you can have dx is equal to du divided by 2 in this case, and then that becomes the integral of u to the power 8 with respect to u divided by 2. That's a pretty simple integral to do. You get u to the power 9 divided by 9. We multiply by the half that was outside, and now you have 2x plus 1 to the power 9 divided by 18, because u is equal to 2x plus 1. So you have to make sure you get the answer in terms of x at the end. And yeah, that's pretty much what it's about, but let's do a harder example, and then it will make more sense. We'll actually understand why it's so useful, because look at this curve right here. The diagram shows the curve y is equal to x plus 5 times the square root of 3 minus 2x, and its maximum point m, so we don't know what that is. Find the exact coordinates of m. Okay, so this is differentiation because that's a turning point. It says maximum point, so that means it's a turning point. Well, we don't even have to do integration. The first part is differentiation. So we find dy by dx. And here we can use the product rule, right? Because we have two different functions. You have x plus 5 as one function, and you have square root of 3 minus 2x as the other function. So what's the derivative of x plus 5 with respect to x? That's just 1. And you multiply that by the original square root 3 minus 2x. By the way, if this does not make sense, then you should watch the video on the product rule, because this is the product rule we're using here. So you have that plus, and then you leave x plus 5 on its own. And then the derivative of square root 3 minus 2x with respect to x. Let's do that over here. So you have 3 minus 2x. I'll write it like to the power half. You want to take the derivative of that, so that becomes a half times negative 2 times 3 minus 2x to the power negative a half, which is equal to negative 1 over square root 3 minus 2x. So not that bad. So you can put that back in here. So you have negative 1 divided by square root of 3 minus 2x. And since the turning point, that is equal to 0. Well, what can we do now? We can just multiply everything by square root 3 minus 2x. So now you have, when you multiply everything by square root 3 minus 2x, you get rid of this right here, and then you multiply this by itself. So that becomes square root 3 minus 2x times square root 3 minus 2x is just 3 minus 2x to the power 1. You have that. And then you have plus, and then negative x minus 5. Because remember the negative 1 over there. And that is equal to 0. Well, 3 minus 2x plus minus x minus 5. So you can put the like terms together. So you have minus 3x minus 2 is equal to 0. And then you get x is equal to negative 2 over 3. Which makes sense because x will be on the negative side. So that's making sense so far. So you have x is equal to negative 2 over 3. Now what is y equal to? Because you need the coordinates. Well, it says it wants the exact coordinates, so we just put it back into the function how it is. So you have negative 2 over 3 plus 5 times the square root of 3 minus 2 times minus 2 over 3. So that becomes 3 plus 4 over 3. So that is, what is minus 2 over 3 plus 5? That becomes 13 over 3. And then here you get square root of 13 divided by the square root of 3. So you can write it as this right here. So you're left with minus 2 over 3 and 13 square root 13 divided by 3 square root 3. 13 square root 13 divided by 3 square root 3. And that's the coordinate. Those are the coordinates of the point M. Minus 2 over 3 and 13 square root 13 divided by 3 square root 3. Now the interesting part, using the substitution u is equal to 3 minus 2x. Okay, so it tells you what to use in this case. So you have u is equal to 3 minus 2x. Let's write that down again. Find by integration the area of the shaded region bounded by the curve and the x-axis. Give your answer in the form a square root 13, where a is a rational number. Okay, it's not too bad. So to find the integral, first we need to know what these numbers are right here. We need to know what this point is, and we need to know what this point is. Well, those points happen when y is equal to 0. So when x plus 5 times square root 3 minus 2x is equal to 0, those are the 2 points we need. So either this is equal to 0 or this is equal to 0. Let's start with this right here. So if x plus 5 is equal to 0, then x is equal to negative 5. Right? So that's negative 5 right there. And then for this point, hopefully it's positive. So we have square root 3 minus 2x is equal to 0. So we have 3 minus 2x is equal to 0 squared, which is still 0. And then x is equal to 3 over 2, which is positive. So that's good. So that's 3 over 2. So now we have the limits. Those are called the limits. And those are the limits of the area of the region we are integrating over. So we have the integral between negative 5 and is 3 over 2. Yeah, it was 3 over 2 of y with respect to x. Okay, so far so good. We have u is equal to 3 minus 2x. So now what's du by dx? Because that's the first step. Well, that's just the derivative of this with respect to x. So this goes away, this becomes 0, and this becomes negative 2. This is just simple power rule. Now we can rearrange, so we can let du is equal to negative 2 times dx. And then dx is equal to negative du divided by 2. So far so good. Nothing too difficult so far. So now what do we have? We have the integral, and I'm going to leave the limits out because you will see why these are actually not the correct limits for this function. So you have the integral of y. Well, what is y? Y is x plus 5. So we have x plus 5. And then we have the square root of 3 minus 2x, which is the square root of u, because u is 3 minus 2x. So we have x plus 5 times the square root of u. And then instead of dx, let's write du. So we have negative du divided by 2. So far not too bad. But we still can't integrate this with respect to u because we have an x right here. We don't want an x. We want a u because that would make everything in terms of u, and then we can integrate that. So since u is equal to 3 minus 2x, we can just rearrange. We can have positive 2x is equal to 3 minus u. If you just bring 2x to one side and u to the other side, you have that, and then you have x is equal to 3 minus u divided by 2. So you have that right there. So now you have the integral. So let's put the minus half right here. So you have minus a half integral of x plus 5. So that's 3 minus u divided by 2 plus 5 times the square root of u, with respect to positive u this time, because we brought the negative outside. Well, we can simplify this further. That becomes the integral of 3 minus u over 2 plus 5 is 13 minus u times the square root of u, and then divided by 2 du, and then we obviously have the negative a half right there. Okay, so far so good. Still remember, there are no limits because those will change. Now we can bring the half over here outside, so we have negative a quarter integral of, and we can expand the bracket, so we can have 13 square root of u minus u times square root of u is u to the power 3 over 2. It's just simple indices with respect to u. And now you see we can actually start integrating because this is all in terms of u. We have got rid of x, and this is an integral that's very easy to do with just the reverse power rule. Whereas if you have to integrate this right here, yeah, good luck with that. I don't know how you're going to integrate that without u substitution. So now you have this right here. Now, what do? Well, we just integrate. So we have negative 1 over 4 outside, and then we have 13 u to the half. If you integrate that, that becomes 13 u to the power 3 over 2 divided by 3 over 2, so that's times 2 over 3, minus u to the power 5 over 2 divided by 5 over 2, so that's 2 over 5. And now we need some limits. So can we use negative 5 and 3 over 2? Well, we could, if you want to put u back as x. So if you like what we did in the first example right here, at the end we put u back, we put x back into this thing for u right here, because u is actually in terms of x. So we put 2x plus 1 back here, and then we got our answer. But now this is a definite integral, so we need some numbers. Now what we can do is we can put the 3 minus 2x back in for u right here, and then we can use negative 5 and 3 over 2. But the other way to do it is, if you have u is equal to 3 minus 2x, then you have the lower limit is equal to 3 minus 2 times the value for x was negative 5 right here. So you have negative 5, and that is the lower bound, that is equal to 13. And then you can use the upper bound as u2 is equal to 3 minus 2 times x, which is positive 3 over 2. This just goes to 0. And you can use that as the upper bound. So instead of putting everything back in for x, and then it's going to look messy and everything, you can just put in 0 and, no, you're going to put in 13 and 0 over here. This seems counterintuitive because why is the bigger 0 is bigger than 13 is bigger than 0. So why is 13 at the bottom? But then you can't change the order around, because over here we had negative 5 at the bottom, and when you put negative 5 back into x right here, you get positive 13 for u. So you have to make sure you put it still at the bottom. And then for here, instead of 3 over 2, we got 3 minus 2 times 3 over 2, which becomes 0. And you put that at the top because 3 over 2 was at the top. So now we have those limits right there. And actually this is much easier to evaluate, because now you have negative 1 over 4, and then when you put 0 in for u, everything just goes away, so you have 0 minus, now is the interesting part. So we have 13 times, you put 13 back in for u, you have 13 to the power 3 over 2. Well, that's just 13 times root 13. So that becomes 26 over 3. That's just, wait, let me leave that bracket open. If you do 13 times 2 over 3, that's just 26 over 3, right? So you have 26 over 3 times, this is 13 root 13. So this becomes 13 square root 13 minus 2 times, well, 13 to the power 5 over 2, I'll tell you right now, is equal to 13 squared times root 13, which is equal to 169 times root 13. You can put this in the calculator if you want, you will see it's the exact same thing. And this is divided by 5. And then you can like put the square root of 13 outside, so you can have negative 1 over 4 and then you have square root 13, because you can factorize square root 13 out from here. And then you have 26 times 13 divided by 3 minus 169 times 2 divided by 5. And once you evaluate all of this, I'll let you have it in my book, so I'll just say the answer. So you'll end up getting something like negative 676 over 15 times negative 1 over 4 square root 13. And then once you simplify that, you'll end up getting 169 divided by 15 square root 13, which is in the form we want. We want it in the form a square root 13, where a is a rational number. So in this case, I guess our a, you can specify it if you want. A is equal to 169 divided by 15. But it's all, you don't have to specify it. You don't have to make this well known, because it's already implied that you're giving it in the form a square root 13. So if you have the square root 13 there, then a is 169 over 15. But yeah, that's integration by substitution. Sorry, not by parts. By parts is the next video. So you might be asking, how do I know what I should use? Like in this case, why didn't I use x plus 5 as my u? And I'll show you how to actually think about it. Let's do it over here because there's more space. So let's say you had the integral of, and I'm gonna rely on you knowing that the derivative of sine is cosine and derivative of cosine is negative sine. So if you take the integral of sine, you get negative cosine. Like it's just the opposite. So like we know that the derivative of sine of x is equal to cosine of x. That means the integral of the cosine of x with respect to x is equal to sine of x. Of course, right? Remember, it's just the opposites. Like what do you differentiate to get sine? Well, you find that. Or what do you differentiate to get cosine? It's just the opposite of what we already know. So let's say you have to do the integral of sine of x times cos of x with respect to x. So how do I know what to let u equal? Do I let u equal sine of x or u equals cos x? Well, in this case, it doesn't really matter. But what you will realize is that what you actually have here is a function times the derivative of itself. You can see that right here. So in this case, maybe it's harder to see, but this function right here, its derivative will be something in terms of this right here. It's very difficult to see right now. But what you can do is, so in this case, let u equal sine of x. Because what you will notice now is that when you do du by dx, you get cos of x, and then you get dx is equal to du divided by cosine of x. Well, then you get the integral of, well, sine of x is u, and then instead of cos of x, well, you can write cos of x right here, and then instead of dx, you have du divided by cos of x. Du divided by cos of x. And these will just cancel out. So you're left with the integral of u with respect to u, and that's very simple. That's just u squared over 2. And then u is actually equal to sine of x, so you have sine squared of x divided by 2 plus c. That means when you differentiate sine squared of x plus 2 plus c, sine squared of x divided by 2 plus c with respect to x, you'll end up getting sine of x cos of x. And you can try it. We find the derivative of, we're not going to do plus c because we already know that's a 0. So the derivative of sine squared of x divided by 2, well, that's just a half times the derivative of sine of x and sine of x again. And now you can use the product rule, and you get a half times cosine of x, sine of x, and then you have plus a half cosine of x, sine of x. And of course, a half plus half is just 1, so you have sine of x, cosine of x. And that is exactly what you want. So you have to realize that when you're looking at these functions, look for a function and then try to look for its derivative. Sometimes you'll be told what substitution to use, like in this case, because this was a pretty difficult question. But sometimes when you have sine of x, cos of x, just think, well, it doesn't really matter what you did, because if you did u is equal to cosine of x and then you took that, you just get positive or negative u. It would end up being the same answer, of course. But just have to realize that the whole point behind this is that the derivative is already hiding inside this right here. And you just have to think, okay, what function can I take the derivative of that I'll end up getting its derivative, which is already in there. So yeah, just do some practice with it and eventually it will make sense to you. It's not that difficult. Just try different questions, make your own questions, do your own substitutions, or like for this case, try using u is equal to x plus 5 and then try using u sub from there. You will see it's much harder, but you will get the same answer. So yeah, like, share, comment, and subscribe, and let me know what else you want to see in future videos.